In this lesson, we are going to take a review and then see if it's positive, negative, or neutral. This is sentiment analysis, and this has many use cases. For example, customer feedback analysis, social media monitoring, brand reputation, market research, product development, etc. Sentiment analysis is a technique in natural language processing to determine the emotional undertone of the text. This is a common method used by organizations to identify and group opinions about their product, service, or ideas. In this notebook, we will apply this technique to the hotel industry and understand customer perception and potential areas that need improvement. First thing that's extremely important is go to your runtime and change runtime type and then use GPU. It must be GPU. It's gonna go, like if you use CPU, you're gonna need 8 hours to execute this, and with GPU, you're gonna need like 20 minutes to execute this. Then we are going to install these dependencies. You have all of them explained, but basically Seaborn is a high-level data visualization, and sentence transformers we use to generate numerical representations, embeddings of text. Then we are going to load and prepare dataset. We use a dataset containing around 90,000 hotel reviews provided by customers. This dataset can be loaded from the Hugging Face dataset hub as follows. We're going to import from dataset, import load dataset, and data frame is equal to load dataset. This is the dataset name, and then split to train, and then to pandas. If we take a look at the data frame.head, we can see that it has review date, hotel name, and review. Now we want to only keep first 800 characters of reviews because we don't want it to be too long, and we can get the sentiment from the first 800 characters. We will use Roberta model fine-tuned for sentiment analysis. We will load it from Hugging Face hub. So to do that, we are going to say import torch, and then we are going to move everything to GPU if available, so it's gonna be like 20 times faster. And then we're gonna, from transformers, import pipeline, auto tokenizer, and auto model for sequence classification. And then the model ID from Hugging Face is this one. And then we're gonna say model is equal to this model.from pre-trained, and we're gonna pass in model ID and number of labels. Those will be positive, negative, and neutral that we will define later. We will also load the tokenizer from Hugging Face, auto tokenizer.from pre-trained, and then model ID. After that, we will create this sentiment analysis pipeline. So we will load the tokenizer and the model into it. So NLP is equal to pipeline and then sentiment analysis. Model is going to be model, tokenizer, and device. After that, we will define our labels. It's going to be a dictionary with label 0 having value of negative, label 1 neutral, and label 2 positive. Now we will see this test review, and it's going to be equal to this one, review 241. And if we take a look at it, it's going to say room was small for a superior room and poorly lit, etc. And if we pass this review through our sentiment analysis model from Hugging Face, we're going to see that we get label to be label 0, so that's negative, and then the score is 0.77. This score is the confidence of the model that it predicted the label correctly. If I scroll a bit down below, we can see that the purpose of our application is to be able to ask a question: are the customers satisfied with the room sizes in London hotels? And then the application is going to actually get reviews and answer this question. To achieve this, we need to actually encode all of the reviews and put it into a vector database. So we're going to use sentence transformer to turn all of the reviews into numerical representations, numerical vectors of those reviews that contain their semantic meaning. So we're going to define retriever. It's going to be sentence transformer, and this is the model that we will use, and device will be our CUDA device. And then we are going to just log the retriever, and this is the retriever that we get. So it has transformer with all of these value, it's going to be birth model. Then it has pooling and normalize. Now we want to initialize Pinecone index, where we will put all of these values, all of these vectors. So we're going to import Pinecone. You need to change set your API key and your environment. So you go to Pinecone and then API keys, and this is environment. This is your API key that you copy here. And then we need to create, we're going to define index name, sentiment mining, for example, and then we are going to see if the index name does not exist in our indexes. And on free plan on Pinecone, you can only have one, so you need to delete if you already have some other index. And we're going to pinecone.create index name, dimension 384. This is the dimension of our retriever model. So it's going to retrieve text in this many dimensions. And then the metric is going to be cosine. We're going to use cosine similarity to measure the similarity between our embeddings. And then we are going to connect to this index. And then this variable is going to store our connection. Now we want to generate the embeddings that we will send to Pinecone. So we're going to define this helper function that says get sentiments, and we're going to pass in reviews. We only need to get labels and scores. We don't need to get review embeddings for now. So we're going to say sentiments, and we're going to pass in all of the reviews through our NLP model. And then we're going to extract labels, and then we're going to extract scores, and we will return labels and scores. So if we say get sentiments and data frame review, we pass in first 3 reviews, and then we convert the result to list. We're going to get the following. These 3 reviews, and then these are the scores. We need to convert the review dates to timestamps to filter query results by a given period. This is helpful if you want to understand customer sentiment over a specific period. Let's write another helper function to convert dates to timestamps. So we are going to import this library, and we are going to create a function get timestamp, and we're going to pass in a list of dates, and then we're going to get a list of timestamps by using this logic, and we're going to return this list of timestamps. So if we say get timestamp, and then we just pass in the first review, and then it's going to be this timestamp. And now we are going to create embeddings. So we're going to define batch size to be 64. We are going to convert 64 reviews at a time. So we have a for loop that goes from 0 to length of data frame, but goes by batch size. So it's going to give us batch size, and then batch size, and then batch size. And then we are going to define I-end. So our batches are going to be between I to the I-end. And so it's going to say I plus batch size. So from I to I plus batch size. But we need to say minimum between I plus batch size and length of data frame, because at the end, if there is not enough reviews to fill the full batch size, then we're just going to go to the end of the reviews. And then we are going to extract reviews from a data frame from position I to I-end, and we're going to assign it to batch. And then we are going to encode all of those reviews into vector embeddings and convert it to a list, and we're going to assign it to the variable embeddings. We will also convert review dates to a list of timestamps, and we're going to add it to batch timestamp. And then we are also going to convert labels, and we're going to get labels and scores, and we're going to add it to the batch as well. We will also get this metadata, and we will create a unique index for each review and add it to the list of indices. If you are confused by any of this, I added explanations right here above the code. And at the end, we are going to upsert everything into our index in Pinecone, and we are going to do it as these tuples. So each tuple is going to have index, embedding, and metadata. So metadata are going to contain label, score, timestamps, etc. This actually took around 36 minutes to generate, and after it's finished, I need to go down really far. And now we can see that dimension, this is the dimension index fullness 0.3, and then total vector count, we have 93,000 vectors. So each of these vectors represent one review, so 93,000 reviews that we have. We have successfully indexed all customer reviews and relevant metadata. We can move on to opinion mining. So if we have a query, are the customers satisfied with the room sizes in London hotels? We will first convert this query into the same vector embedding as we did with our reviews. So retriever.encode query, and we will convert it to list. So we have this as a list. So this is going to be our vector embedding. And then we're going to index.query, and we're going to pass in this vector embedding, and we will retrieve 500 most relevant reviews or 500 most similar embedding vectors. And we will include metadata. So if we take a look at first two reviews, we have this one is neutral, this is the review, and then this one is positive, and this is the review. We can also check the last two reviews, so it's going to be positive, positive, these are the reviews. And now we are going to count how many negative, neutral, and positive reviews there are in these 500 most relevant reviews. We're going to create a small function that's going to take in the result, and we're going to create a new dictionary, so it has negative 0 reviews, neutral 0, positive 0 reviews, and then we are going to count, just add 1 to each of these when each of these reviews appear. So we're going to say that we have least amount of negative views, and then neutral views, and then positive views. We can also plot this onto this graph using this syntax. As we can see, the customers are generally satisfied with room sizes, although many are still neutral or negative. And now I'm going to show you how to get reviews from only a selected period of time. So we can define start time. We're going to say get timestamp, call our function and pass in the time. And then we're going to say end time and pass in the time as well. This is going to be pretty similar as the way we already retrieved information. We're going to have the same query, and we're going to use same encoding for that query. The only difference is when we are querying the Pinecone index, we are going to add this property as well, filter, and then we're going to say timestamp greater than or equal to start time, and then less than or equal to end time. This is the Pinecone syntax that you just need to know or find on the internet in their documentation. And this is going to show us that in between this time period, we have this kind of sentiments. So 250 positive and around 230 negative and neutral. And now we are going to question particular hotels. So we have a list of queries here, and we are going to question room size, cleanliness, staff, food, AC unit. And we're going to define a dictionary of queries. So room size, are customers happy with the room sizes? And then all of these queries. Now we're going to extract all of this information for all of these hotels. So we're going to say hotel sentiments. We're going to create an empty list. And then we will loop through each hotel. We're going to create an empty list results. And we will now loop through each of these elements. It's going to say area and query. So this is going to be area, the first key, and then value is going to be query. And then we will do the same thing. So we will convert the query to a vector embedding. We will query the Pinecone index, and we will pass in the filter. That's going to be hotel name. And then we are going to count the sentiments, and then we're going to create a new dictionary, and it's going to say area, label K, value V. So basically, after we append all of these results, we are going to get the following dictionary. It has these IDs. It has area, room size, label, negative, neutral, positive, 127, 187, 186. So I forgot to mention that we are only checking the first hotel here. So for the first hotel, we have room size, negative, neutral, positive, cleanliness, etc. Now you understand what we did in this code. We can also plot all of this information down below. So as you can see, this one hotel has all of these negative, neutral, and positive labels. This is the second hotel, third hotel, fourth hotel. We see that this one has a lot of positive labels, for example. What we can learn from this is, for example, let's take a look at this first one, Standard Palace Hotel. Most customers were pleased with the staff, food, and cleanliness of the rooms, while a considerable number of them were not very satisfied with the room size and AC unit. At the end, if you want to, you can delete this index. So that was it for this course. Hope you learned a lot. This technique has endless real-world applications. Hope you enjoyed and hope you learned a lot, and see you in the next lesson.